Alright everybody, welcome back. My name's Andrew. This is the Make It and Break It YouTube channel. Behind me is a 2010 Subaru Forester Premium, I think, not the Turbo, which is the XT version. And I'm doing some work for a friend on this, and she's having some troubles with her engine. Specifically, her head gasket is starting to fail. This is a pretty standard problem for some relatively modern Subarus. And it's just something you got to keep aware of and fix every once in a while. So today we got the engine on the stand here, you can see, and we're actually going to go pull it apart, get the heads off, and then get the heads to a machine shop and do the rest of the cleaning stuff. Let's give you a little tour around the engine, and then we'll start working. All right, so this is the front. This would be if we'd be looking in at the front here, if the engine was installed, and this is kind of what a Subaru Boxer engine looks like. So it's a Boxer, which means it's a horizontal. It's a horizontal setup. So normally, I say normally when I mean like most cars on the road have an inline or a V shape. So an inline is their vertical. The pistons go up and down like this, or V shape. The pistons are offset and they go in a V. They run up and down in a V shape. If you're a car guy, you can just skip forward or doing something here. So the Boxer engine has pistons right here under these black covers. Well, actually, they're kind of behind and in the head, which is over here. But the pistons run along this black cover line. Which means it does some cool things for the car. It lets you it lets you sink the weight center down a little bit, so that essentially all the weight in the engine is lower in the engine bay, which will give you better handling. It's one of the reasons that Porsche uses a Boxer six cylinder. So this one's got 4 pistons, so kind of like any sort of 4-piston thing. Porsche uses a flat 6 version of this engine. Major pieces, you got the intake, which is this cast piece up here. And the intake actually carries most of the engine harness, this upper engine harness. So that's going to come off with a lot of the wires. So we're going to have to pull off wires over here and over here. And then you've got your main engine block, which is actually in a Boxer engine like this, the engine block isn't one piece. So you can see kind of right in here, this bolt set, the actual engine block will split, and you can split the case. If you're going to go work on the main crank where all the pistons attach to. But we're not going to do that today. We don't need to do that. So you have your main engine block here, and then here and here, these metal parts are the cylinder heads, and that's where the head gasket leaks. So the head gasket will leak on these things, kind of in this. Where is that joint? It's easier to see on this side. So this sort of separation joint right here, you can see that head gasket will leak, and that's a kind of design flaw on Subaru's part on the gasket material. And the gasket design, it's a single layer steel gasket with some other gasket material on there, where most successful gaskets on an open deck design like this are multi-layer steel. So they will fail eventually. Usually they fail and start leaking externally, and if you leave them long enough, they'll fail and leak internally, and you'll get oil mixing with water and blow out all the bearings, and it's bad. But that hasn't happened yet. The owner caught this one really early. Should be easy. Just go disassemble parts we need and pull her on out. Let's get to it. All right, so we have taken the heads off here, so you got everything off and where it wants to be for now. Just a jumble of parts and crap over there. Quick inspection. I didn't see anything horrific. So looking down here, this is the top of the head. So this would be your head gasket would go on this surface and your head stacks on top of that. And I'm not seeing like ridiculous signs of seepage past any of these gaskets. And I didn't really see too much gasket degradation itself. Although, like on this side, I saw a little bit of gasket degradation right here. And similarly, I saw some down over in here on this side. So that could be what was causing our problem here. But they didn't look horrible, which means we probably caught it very early. So that's good. And hopefully that means the heads and everything are going to be pretty straight. This is a pretty new engine, relatively speaking. Obviously, it's 2010, but it's not. It doesn't have a ton of miles on it, so hopefully nothing has warped too much yet. And then sitting down there are all the head bolts. So the thing to remember about this engine is that the head bolts are not torqued to like a specific number, like a foot-pound number you might be used to looking at. They're actually stretched, and that elongation is used to calculate how much torque or how much force the bolt actually applies to the head. So as it stretches, it actually applies a lot of force in this direction. So it's actually, when it's done right, it's a very it's a more consistent way of measuring your force and making sure your fastener forces are correct. It requires a little bit more attention than just putting a torque wrench on it and torquing it. But you can account for things like differences in lubrication and that sort of thing. If you're nerd out time, sorry in advance. So if we're torquing a bolt like this, right? This is a head bolt, and this is actually one of the center head bolts because it's got a colored top here. Let's focus in. Yeah, there we go. See? So this bolt, if we're torquing it in, we're just torquing it like this, and at some point the bolt head is going to rest onto a firm surface, and that's when it'll start getting harder to torque, because what you're actually doing is stretching the bolt a little bit. So when you just put a torque wrench on it, come here. If you just put a torque wrench on this bolt, right? What you actually get is the difficulty of turning this head, which is not the same thing as the amount of force that's pushed along that this bolt actually is holding with. It can be affected by a lot of things. Specifically, the biggest one is lubrication of the fastener side here. So lubrication of this side can make a huge difference on your resulting torque with a torque wrench on the other side. So what elongation torquing does is it measures the amount of change in the length of this fastener. So as you elongate it, it actually stretches a little bit, and that stretch corresponds to a certain amount of force along the fastener. And that's a lot more precise when you're not worried about differences in lubrication and everything else. It's maybe just slightly more precise. It's a different way of doing things. The old way of doing it works just fine for most applications. It's just sometimes you want to be a little more precise, and a lot of head bolts and head studs are like that. So a little bit of insight into what's happening here. And here are the heads that we removed. So I have them facing different ways, mostly so I can just show you what's going on here. Your heads typically contain your Valvetrain, which is what we're seeing here. This is the top side. So this would be facing out towards the wheels when the engine is installed. And so this is your Valvetrain here. And that's all your valve springs in here. These are your spark plug tubes. So this motor, the spark plugs come all the way in and they come into this hole here, and that's where the spark plug is. But you have to be able to access those from the outside, so they have these big long tubes that go through the entire head. You saw me pulling the spark plugs out of them on the disassembly. And then here's your camshaft runs right through here, and it has little arms that go out and push on these valve springs. So this is your outside version of it. And then here's the inside. So this would be where the cylinders. So we're getting a cylinder point of view here. So you see, you have your intake and exhaust valves. Intake valves are always going to be bigger because they don't have the cylinder pressure to help them evacuate. Because you're essentially getting everything sucked in. So you got your intake valves and your exhaust valves. You can tell this part is not quite on top dead center, because this valve is actually sticking out. You can see it's off the seat. It was just coming off the seat. I'll make sure I get this thing reset. I'll make sure I get this thing reset before we turn the engine back on, because if the valve train's off between each other and the cylinders, bad things happen. Pistons hit valves and break things, and the engine runs really terribly even if it doesn't break things. So we'll make sure we get this right before we go in. But this is the cylinder side, and on this side you can kind of see the passages. So these are coolant and oil passages. I believe these are oil passages down here. Most of these, I believe, are coolant, and these are the things that leak. So when you say a head gasket leak, what that means is you're either getting a leak into the cylinder from one of these coolant or oil passages, technically to the outside, and typically Subarus will leak to the outside first, so you'll get a leak from this oil passage out, or you'll get an intermingling, so you'll get a leak between this coolant passage and this oil passage, for instance. And that's really bad, because what that does is it gets coolant into your oil, and then that puts coolant through your bearings, which will chew up your bearings and basically junk your entire motor. So if you let this problem go too long without fixing it, you'll actually just have to get a new motor or junk your car. So that's why it pays to fix your head gaskets if you're having some leak by, so that you don't have to junk your entire motor. You just have to pull them off, replace the gasket, and get this thing fixed up. So these are actually going to go to a machine shop here. So they look really good. I don't see any real blemishes on it, but you want these heads to be very, very, very flat. The flatness is not just a perfect thing. It's a variation in the surface, but you want these to be very flat so the head gaskets work appropriately. So what you do is you send this out to a machine shop, and they'll go check and make sure that the plane that this surface makes, so this sort of plane right here, they'll make sure that that's very flat, and they'll probably take a little bit of material off. And then you can also have them check your valves, make sure your valve seats are good, make sure you're getting good sealing on your valves, so you're not getting back pressure into your intake, or you're losing power because your exhaust valves aren't seating properly. So that's why you send this off to a machine shop. Some shops will go and do this replacement without sending the heads off, which it's gonna work okay initially. It really will. The gasket will seat itself just fine, but it will fail a lot quicker than if you send it off to a machine shop and send it out. Yeah, that's kind of the head. So we're gonna get these sent off, and then we'll get back in there to finish up our refurb of the engine with a couple of the other parts that you might as well replace while you're in here. All right. So we're back. Heads are back from the machine shop. They're sitting in there right now just because I don't have a bunch of space for them out here. We've gone through and cleaned up this gasket surface. It's not pristine like we took an actual war brush to it, but there's no raised pieces anywhere in here. So basically cleaned it up, made it a good, nice seating surface for our new gasket. Did that on both sides here. So now we're going to start the long and torturous process of installing everything back on this thing. So that means getting the heads, new head bolts here. We are going to blow out all the head bolt areas one last time with air, just to make sure there's nothing in them. And then we'll start reassembling everything. So let's go to it. Hey everyone, that sort of looks like a complete engine, kind of. So as we sit down here, you might have seen me if I bothered to put the time lapse in. I'm not sure how good it turned out, but I replaced all the idlers. And actually this is not an idler necessarily, this is the tensioner with the hydraulic piece here. As well as we got a new belt. Tip on the belts, let's see if I can find one of the marks here. So a lot of belts, not all of them, but a lot of them will come with these marks, and these marks are generally supposed to line up with your timing marks right here. So this one actually did line up. This one actually did line up a few rotations ago before I checked it. And there's one probably sitting right under here that lines up with this timing mark and what have you. So there's timing marks around here that lined up with our timing marks initially. And that helps you set the belt on the right tooth. I was having trouble with this one because I was one tooth off. But that helped me get the belt set up correctly. So that's a tip. Normally we'd be right into throwing a bunch of stuff on here, throwing our cross connect on, throwing our intake, all that sort of stuff. But we actually have to do one check here. So the guys the shop who machined my heads, they did a pretty good job. But they did tell me that they may have had to adjust the valves a little bit to get them to seal on their machine. So I really need to go recheck the valve clearance for all these things. And that's actually pretty simple on a motor like this. So what you're going to want to do with that is put the motor in top dead center for each cylinder, which means right now in top dead center, top dead center, top dead center, which is where I'm sitting right now. That's top dead center for cylinder number 1, which is the front passenger side cylinder. And then what you do is you go into the Valvetrain, and we'll look at this side since it's a little bit more accessible. So this is your Valvetrain here. This is your intake valves up top, exhaust valves down on the bottom, and you can see this little rocker arm here. So this runs on the cam. When this lifts up, it forces this down. Essentially, is how your Valvetrain works. So right in between them, there's a bit of a gap. That gap is there, so when the engine heats up, the valve expands. And when it expands, it essentially just lengthens. And so what you don't want is the valve to be run constantly on this, and therefore not sealing. It'll cause you to lose compression in your intake. Your engine will run really bad if your valves are out of whack. So what you do is you go to top dead center on that cylinder, which is all valves closed essentially. And then in the intake valves, you take a little feeler gauge like this, and for these motors, the spec is 0.008 or 0.2 millimeters, and you shove the little feeler gauge in between the two pieces here. Let's see if I can. There's a couple pieces right in here. We shove the feeler gauge in there, and we make sure that we have that set appropriate. If we have to adjust it, then we adjust it by messing with these screws. So you put a little box end on this, unlock it, adjust your screw, and then lock it back down. So we need to go do that real quick. Just sanity check all of our valves here because the machine shop said so. So we'll do that real quick, and then we'll get back to the build. Believe it or not, behind me is what looks like an engine again. So we've got all of our covers back on, we've got all of our heads and our intake, and pretty much everything that I can connect right now is connected. And we're set up to rig this thing into there. But that'll happen tomorrow, probably. Because it's late and I need to go to bed. Just complete disaster area right now out here. I'm gonna have to clean that up before I start rigging anything around. That's gonna be fun. Anyway, I think that's it for us on this episode. Next time we're gonna put this thing back together, fill her on up, and hopefully nothing leaks, because that would be really annoying.
Thanks for watching, everyone. My name's Andrew. This is Make It and Break It. If you liked this video, if you found it entertaining, interesting, informative maybe, definitely hit like, comment down below if I missed something, or if there's a better way to do one of these things, because this is not the be-all and end-all how to do it. I'm just like showing you guys some of my work as I go along. So definitely comment down below, help people out. And then if you like what we're doing in this channel, we do random stuff like this sometimes. We've got an RX-8 project going on. We've got a Yamaha R6 build going on. Some other stuff that's coming up. So if you like any of that, definitely subscribe and ding that like bell button, subscriber note, the notification thingy. And thanks for watching, everyone. It's the night for me. I'll catch y'all tomorrow.